fans, and welcome to another episode of the Hambini Show, which is the weekly, well, maybe monthly, maybe even bi-monthly attempt for me to be sarcastic, humorous, and deliver a certain amount of engineering intelligence at the same time. In today's episode, we have two things that are possibly the greatest things since sliced bread. We have this. Behold the Look 695 SR. So if you regularly watch the channel, you will have seen maybe a few videos ago just a normal Look 695. This is the SR model with its Z Crank Set, and to all intents and purposes that crankset is the dog's bollocks. That is the testicles of the dog. Die Hunteier, I think I got that wrong in German. And the little twerk that we have, the twist that we have, is we need to fit a Campag crankset to the frame. So, let me talk you through the frame and some of the little foibles and things that we have to go through, including the wave washer that I've just dropped. So this is the Look 695 SR Z2 crankset. I've had this checked, and the NDT guy said this was pretty much the dog's bollocks. The only thing that is worthy of note is on this side, I'll put the bike down, over here is what looks like a crack. It's not, it's where the chap took his the rest of his paraphernalia off, and it's cracked the paintwork. So I've just had the rest checked. There's hardly anything wrong with it. There's the odd void here and there. Well, when I say odd void here and there, there's two, both which were minuscule and well within acceptable tolerances. This bike comes with a BB65 bottom bracket, so it's 65 millimeters in diameter. So the outside is 65 mil, and it has a fixed bearing on one side and a well, I'll take it apart so you can see it. So if we get the Allen key, I think it's 3 mil. Just undo. Oh, it's already undone. This must be 2.5. Yeah, it is. So if we undo that, what Look have done is in the other side, I always think this is well designed, is they put a slot so you can put the Allen key in and turn the preload collar off. Okay, so that is now loose, pretty much. You can take that off. So that's their preload collar, and there's a shim by the looks of it in there, yeah, which we need to extract. And I can't quite get my fingernails in there. Might have to, I don't think it's that important. It's not. So we can take the bottom bracket or the crankset out now, and it just literally comes through like that. So it's one piece. It doesn't really get better engineered than that. So this is carbon. Got metal seats. That bearing doesn't feel too bad. Well, I mean, when I spun it, when I got the frame, it did feel a little rough, but I couldn't tell which side it was. Oh no, it is that side. You can just about hear it. And that one feels fine. So these are 6810 bearings. So this one is fixed into the frame. The one on this side is fixed to the crank, like that. Okay. This crankset allows you to have 170, 172.5, and 175 all on one arm. Not sure what make these chain rings are. I've never heard of them. Nereus. Anyway, okay, so they're the chain rings. I think usually they come with Praxis, but someone's fitted a Campag bolt in there. So that one's looks like a TX. The rest are hex. So that's the aftermarket job. Right, the next thing we need to do is we need to get this bearing out, and we can just literally tap that out. So I'm going to get a piece of wood and rig something up to get that out. Bit more hammering. And the bearings out. Now the next job is to clean this all up. There's no real damage on this seat, it's in good condition, but I will check it in any case. There is a couple of differences between this frame and the one that was on a previous video, and the most obvious one is there are no holes in this bottom bracket. So it's aluminium one piece, but there's no Di2 holes anywhere at all. I think that's mainly because it exits out here, goes round, and appears to come out there, so it's designed for mechanical. But nonetheless, I'm pretty sure if someone wants to drill a hole through for Di2, I don't think it'd be particularly difficult to do. There's even a hole there for the dropout. Not for the dropout, sorry, for the rear mech. So we need to check that. So that's really all we can do with the frame so far. Just need to check that. Now we come on to the crank. Now you might be wondering why I've got two Campag cranks. So we've got a Campag Super Record and a Campag Record. The Super Record one, this one, was the original crank the guy sent me with the frame, and he wanted this fitting to that. Now when I checked this was not straight. So the bottom, the crank axle, once you line up the teeth, was not straight. So that was the issue with that. So after I told him about that, he sent me this one, which is a new Campag Record crank. Now the design features of both of these are very, very similar. So you've got I mean, the key feature is the hearth teeth. So these teeth on here, they're incredibly difficult to machine. A hearth tooth coupling is a way of centering and indexing at the same time. So it locks in like that, and there's the bolt goes through the middle to lock the two halves in. The Campag design philosophy is somewhat different because unlike all the other brands, so that's mainly Shimano and SRAM, the interference fit on Campag is on the male component. So it's like a cock ring really. So the bearing inner race is in tension, the outer race is loose. Some other key attributes with this, or some I don't know, some Campag quirks, the axle in this case is titanium. It's completely unsuitable for aluminium in this. You can't really do it in aluminium. It has to be titanium or steel. But the strange thing is, on the Record, the bolt that goes through the middle is a right hand thread, and it is on all of them apart from the Super Record. On the Super Record, the bolt that goes through the middle looks to be a left hand thread, and so I don't know what they were thinking with that. I don't know why you just don't have parts commonality all across the range, but there you go. The other, I don't know, strange thing are these bearings. So these bearings are FAG or Scheffler Chronitect. They have the name Cult. They're a ceramic bearing, so ceramic balls onto a very, very hard set of races, and the actual process by which these things are hardened is a bit of a trade secret. So Fag know, or Scheffler know how to do this, and they're not really going to tell the whole world. So they have very, very low rolling resistance, but they're not immune, because you can hear the bearing has failed there. Another quirk, which is the kind of thing that really pisses me off, is this is a non-standard size. So this bearing is called 6805N. So it's 25 on the ID, 37 on the OD, but it's only 6mm wide. A standard 6805 is 25mm on the ID, 37 on the OD, and it's 7mm wide. So this is a non-standard bearing. The other quirk, I really don't know why they've done this, is well, you've got very, very low friction bearings in terms of their rolling resistance, but they have a load of cage friction, and the exterior seal, which I'm hoping can just about, oh, let's put it into manual mode. So the seal on the outside, probably not so apparent on that one, maybe a bit more so on this one. Seal on the outside is way bigger in diameter than the bearing, so you're going to get absolutely footloads of drag from that bearing. So you've got very, very low friction bearings in terms of their rolling resistance, but the seal is just going to kill it. So there we go. But in terms of manufacturing, you know, this is pretty much the gold standard for complexity. If you compare that to the Zed Crank Set, so the Look Zed Crank Set, I mean, this for me is like a work of art. It's an engineering art in terms of the composite technology and the way they've done it. This one, the Campag Crankset, is just like a machinist's wet dream, really, isn't it? Okay, so there's that, and then finally we have the robotic Japanese machine, which is a Shimano Crankset. Very simple, and comparatively, compared to the other two, extremely cheap to make. They don't have to go through anywhere near the manufacturing procedures that the other two have to do. So, and that's really a Japanese thing. They are the masters of manufacturing, and you know, this is an example of that. So you've got steel axle, and the preload system on this is, and in fact I haven't really spoken about preload systems. This one uses a displacement preload system. So this preload nut moves that crank arm forward and backwards to give you the preload on the bearings. On Campag, you have a wave washer. If I ever find the damn thing again. You have a wave washer which goes on to the axle, okay, and then compresses the outer race. I'll show you that in a PowerPoint. And then the Look Zed system. The Look Zed system is like Shimano because it uses a displacement preload system. A displacement preload system is miles better than the wave washer, because frames are made to a tolerance of plus or minus, you know, a millimeter basically. They'll say 0.5 millimeter, but it's basically a millimeter. So you've got plus or minus, you've got a range there of 2 millimeters. 2 millimeters on that wave washer is the difference between, you know, a small amount of preload and fucking shitloads of preload. Or if you're on the other end of the spectrum, between no preload and a bit of preload. So that's where we are. Next we have the PowerPoint. All the way from inside of here, we have what is going to be I'm so famous for this, is the PowerPoint. Right, if you're not familiar with what happens next, the language and the wordage gets a bit more colourful. So we have, you know, the use of language in English, French, German. I mean, some people call it brilliance. Some people call it arrogance. Some people call it nerd porn, and other people call the police. Hambini the Bambini rams it into some smegheads from over the border. Now, if you are unfamiliar with the word smeghead, go look it up on Urban Dictionary. And if you are on the Urban Dictionary wondering why there's a load of people typing in smeghead, that is all due to some immature 5-year-old prick on YouTube who thinks it's funny to have ridiculous titles in his PowerPoint to garner more YouTube hits. At least I'm honest. Right. But by Hambini H5. Right. At this point, I always talk about my fucking t-shirts, and because I've been shafted by some people by not providing my t-shirts. So they've taken all my money, but not provided the fucking t-shirts. So they need a dose of Cyclone. Anyway, let's move on. Campag. This is not going to be a full-on roast video. This is going to be how we get this fucking crankset into this frame. So that's the crux of it. And it's more focused on Campag than it is on look, because I've already covered look. So have a look at the look video, which is the most beautiful crankset and bottom bracket in the world. I'll probably link to it below. So yes, Campag. Tullio Campagnolo started the company off at some point. His most famous invention was the quick release skewer. So 80 years after the quick release skewer was realised, we've now got through axles. So that's 80 years has been required to get over that hurdle. They have been in business, according to their website, since 1933. They are based in northern Italy. Pretty place. So if you've ever been there, there's loads of hills and loads of cyclists actually. Also, if you are not unfamiliar with Italy, there's a load of also crazy people on the autostrada who will want to kill you, because Italian driving is known throughout, Italian and Spanish driving is known throughout the world for being somewhat adventurous. Right, Shimano SRAM are the main competitors. So Campag is mainly focused on road, tri, disc brake, rim brake, electronic and mechanical group sets. So that's where their focus is. I have no idea if they're publicly traded or run by accountants or privately held or whatever. If someone in the comments wants to comment, then please do so. Right, let me show you the Campag website. So this is the Campag website. The bit that we're interested in is Ultra Torque. So Campag Mechanische Technologien. I'm not sure why I've set this to German. It must be because I'm not even sure why it's on German. It's defaulted to German. Not sure. Right. Anyway, this is, I mean, the bane of what follows, really. So, I mean, that's the Ultra Torque system, is this Hearth coupling, which is like the be all and end all. A bolt through the middle of it, and we go from there. Now, if you look at, I'll click on Renrad, it's a racing bicycle. These are the Campag group sets that are available in kind of descending order of expense. So Super Record is the most expensive, 12-speed electronic, and then you've got Super Record 12-speed mechanical. Then there's just Record, Chorus, Potenza and Centaur. So Centaur is the bottom of the range, Potenza, and then Chorus. So as with many other group set manufacturers, the 12 speed is trickling down. So the Super Record's got 12 speed, and then it's fuck coronavirus. Sorry. So yeah, it's just trickling down. The bits that bolt, the interface that bolts onto your bike is all the same, so you can interchange the bits fairly easily. Right. Let me take you back to the PowerPoint. Right, the key features, the bits that are pertinent to this install. Campag has a 25mm shaft. Shimano is 24mm. SRAM is 24 or 22. Well, it's 24 and 22mm on a GXP, 29mm on a Dub. They also have 30mm. And then Rotor, FSA, and Cannondale are 30mm. The key difference, and it's a huge difference, is this is the only widespread bottom bracket design out there, it's Ultra Torque, where the interference of the bearing is on the inner race. On all the other ones that I've highlighted, so let me get the pointer out and point it. On all the other ones, so Cannondale, Shimano, well, all of them, the loose fit is on the shaft, whereas on Campag it's interference on the shaft. So the shaft is in tension. If I get the bearing out, the famous cutaway bearing, we've got an interference fit there and it's loose here. And you've also got an interface between machined surfaces. So if you were to pick a BB30 bottom bracket, now a lot of Cannondale bikes, that is not a machined surface. It is just like a rough, straight out the mold surface. Or if it's on a BB86 bottom bracket, some of those cups are blown. They're not machined. But on a Campag crankset, by virtue of what it is, they are machined. Right, the hearth joint is the split. So you've got the joint in between. I've just shown you it, and I've just shown it in the video, that where the two halves join together. And this is, well, Scheffler, which is FAG. So FAG, they make the bearings for some of the bottom, well, not bottom brackets, it's the cranks that Campag use. They're not standard across the range. They're called Chronitect, which is a martensitic hardened steel. They're not standard across the range, and the Campag, you know, the way it's set up, it has a wide bearing spacing. Finally, and this is the bit that's slightly wankish, is it's a 6805 N bearing. So you've got 25 by 37 by 6. So they are a non-standard size. A standard size is a 6805, which is 25 by 37 by 7. So there we go. Right. Interference on the inner race. So this is like a section from a bearing. So you've got the side-on cut shot through there, and then the front. So the inner race is here. So that is this metal piece here. That's the, oh bollocks. That's the metal piece. That is in tension, and that is basically the industrial standard. If you were going to go pick a big machine out in the real world, you'd find the vast majority of them have the interference on the shaft. In practical terms, it has a higher load rating. So, you know, technically the Campag Ultra Torque is superior because of this. It's also easier to machine an external diameter than it is an internal. So if you took a bottom bracket as an example, it's easier to machine the outside than it is to machine the inside. And that's just the logistics of where the cutting tool is and where you can see it and stuff like that, and deflection. And the reason why an inner race in tension is better is because when the inner race is in tension, you need a huge force to break it, but to implode it, which is what it would be like in a Shimano bottom bracket, you only need a small force. So as an example, if you were to get, say, a cylinder like this and then fill it full of put an end on it and then pressurize it, you would need a massive pressure to blow that apart. However, if you sealed it and then went down in the sea, you wouldn't need to go that far before the water pressure crushed the outside, because it's weak on the outside, but it's very, very strong on the inside. That's why submarines have extremely thick sidewalls, The metal is really, really thick compared to an aircraft where the sidewalls are very, very thin. Even though they're very similar in cross section, you know, round, the hoop stress is more beneficial when you've got positive pressure on the inside. Right, this is like the Campag paradox. You've got the world's fastest bearings, so the Campag cult bearings are probably the fastest, which are these things here. Okay, and then you've got these two, this seal, which is this piece here. Now if you were to zoom in on that, that's the edge of the bearing. The seal comes out by a fuckload. Like 0.3 millimeters it comes out to engage with the with whatever it's going into, and that is loads. You can feel that as it's going round. I mean, 0.3 is a conservative number. You know, I wouldn't be surprised if it was like 0.5, 0.6, 0.7, because, or even a mil. It's just difficult to measure because it's flexible. So I don't know, that's just ridiculous. And that seal is not part of the bearing. So the bearing sits separately, and then you've got this seal that sits outboard of it. There is one disadvantage with this type of seal, and that's because it's a semi-lip seal, so you can get dirt into there. I mean, it's probably, I don't know, 80 shore hardness, 80 NBR, which is nitrile, and you can get dirt traps in there, and it'll just act like grinding paste, and that'll put a track in the bottom bracket. To counteract that, you would need to put a lot of effort into cleaning thing. So, you know, that's it. See, and this is it. You've got, I don't know, the fastest bearings and the most draggy seals. It's crazy. This is a schematic of the Campag bottom bracket. So you've got one bearing here, another bearing here, and obviously it's interference on here and here. The hearth joint is there. I've said about the interference fit. Ah, yes. This thing here is the wave washer. The wave washer gives you the preload. In order to adjust the preload, you have to adjust here by shimming. The problem with the Campag bottom bracket is, I mean, if you have a Hambini BB, the size is fixed, but if you have just, you know, threaded into a frame, the frame is plus or minus a millimeter, so you could have a range of 2 millimeters. 2 millimeters of preload is like shitloads. There's an interference fit there, transition fit there, and transition fit there. I mean, it doesn't look that complicated, but this business about the shimming, what a tomfuckery that is. Jesus Christ. Ah. Right. If I explain how this preload works, the Achilles heel, let's say you've got extension and force there. If you have a narrow frame, and let's say it was 66 millimeters, you might be at this point here. So you go to there and then over. If you have a frame that is 70 millimeters, and that's still, sorry, 66 millimeters. Let's say 67 millimeters, so let's label that 67. If you have a frame that is possibly 69, which is over here, yeah, you've got the same crankset with an increase in preload of that much, which is unforgivable. It is completely unforgivable. So I don't know, it's difficult to deal with that sort of margin. So the preload on the Campag is difficult to contend with, and that's been the biggest trouble with this crankset, and one of the main reasons why I've tried to avoid making them for Campag in the past, because you need that adjustability. As the thing wears, so the bearings wear out, you will need to adjust that preload, and you will always need to add more to increase it. Add more shims to increase the preload, and it's just a pain, a right pain. Right, let me show the 3D. Right, let me show you the 3D. Keep. This is a cut through a Shimano BB65 bottom bracket on the Look bike. So you can see the bottom bracket is effectively symmetrical. So you've got a bearing here, inserts here to take you down to 24mm, a lock ring here, O-ring here. One of the viewers on the German Tour forum, who obviously knows a lot more than me because he's German, and therefore of superior intelligence, asked how did the Di2 wires go around. Well, in here there's a gap, so that's the edge of the bottom bracket and that's the edge of the Look frame, so you've got a huge gap to route your wires around. Now on this frame it doesn't have the holes drilled, but if you did have, and the frame on the last video did have, you could route your wires around there. So that is how the the Campag bottom bracket works. Sorry, that's how the Shimano bottom bracket works. The Campag bottom bracket is slightly different. The Campag bottom bracket is asymmetrical. So this is the drive side, so that bearing is fixed, so everything comes off that datum, and this is the non-drive side. So that non-drive side looks really wide compared to that one, and that's to allow for shims to be put in here, so the wave washer goes in this side and gets shimmed outwards. That might sound quite easy, but it's a bit of a fiddle getting the right dimensions. I mean, who has got a lathe to give you a 37H7 fit on the outside diameter, because most shims aren't in that size? It's just a faff. So I bet loads of people have put these wave washers in and not adjusted the preload. So, you know, I just don't know. Right, let's go back to the PowerPoint. Right, you were probably not expecting this. The return of the cuntish shitbag scale of engineering fuckwittism. If you end up on here, you really are either fantastic or shit. Right, on the right hand side we have the lick, the shears, which is not quite as good as the lick, not a shitbag, borderline shitbag, definite shitbag, cuntish shitbag, and speck of shite on the Angels of Humanity. Now, to give you some, guidance as to where Campag is supposed to be, I've put their competitors in. So first of all, we have SRAM. So they are in definite shitbag, borderline shitbag territory. SRAM tolerances are crap. So that's where they are. Also on this list, we have bollock heads who believe wider tyres are faster, because they're not. Spokeless CFD. I mean, who the fuck goes and does a load of CFD analysis and forgets to put the spokes in and then writes a 5-page white paper or essay on how good their CFD is without having the spokes? Commenters, I'll leave that one to you. Right, spreadsheet wankers. So that's people who spend too much time on spreadsheets, generally have small penises and repetitive strain injury. Shimano. Now, Shimano used to be a bit more over here in not a shit bag, but then all of their cranksets started failing, so I moved them. The Look 695. This is, now I've had several through here, and that is the dog's bollocks. I would go and buy one. In fact, if someone's got one for sale, email me, especially if it's new, because I'll probably bite your arm off and buy one. So Look 695. The German Tour Forum in not a shit bag. Please do look me up on the German Tour Forum. It is hilarity. And fuckwits who don't understand tolerances, and there's lots of them in the cycling industry. Stay Steady state wind tunnel test. The days of the steady state wind tunnel test are completely fucked and numbered. And then we have, where are we going? Campag Record. I put it in between not a shit bag and the shiz. So that's where it is. But that wouldn't be giving you the whole story. So they have a double entry in cuntish shitbag territory as well. So, and this is it. The Campag has some bits that are truly brilliant, and then some bits that are utterly fucking wank. So that's the paradox of it. I mean, the manufacturing quality in terms of tolerances, fit and finish is very good, but some of the quirks I just can't get my head around. So that's where they are. You're going to get a bit more of a detailed view in a dedicated video about this, but this is just to put this into the look back. Right, let me take you back to the workshop. So this is basically the exterior of the bottom bracket. This is the locking system. This, since I made the bottom bracket for the Shimano Crankset, lots of people have used these and the feedback's been very good. So this is the first time I'm making one for a Campag crankset. Now it looks very similar to the Shimano one. A question I had from a number of people is, where do the Di2 wires run? Well, the Di2 wires, if that's to push on there, I don't really want to push it on too tight because I'll never be able to get it off. Let me grease it. With some PTFE spray that I got from Obi. That's still not enough. Maybe it won't be as an O-ring. Never get this off. Okay, so this is the bit that goes into the bike, and that's the locking ring. The Shimano system is absolutely symmetrical across both sides. The Campag system isn't. Campag bottom bracket is slightly wider than a Shimano, and on one side, namely this side, so I've made this the non-drive side, that is where the preload system is going. Now, this is the preload washer, and it is the bane of all fucking nightmares. That is a bit of a bastard, really, because if your frame is slightly too wide and you have a normal two-piece bottom bracket, when you put it together, you're going to end up with a mismatch in preload. So what you have to do is you have to shim it. In this case, the bottom bracket is a fixed length, but I wasn't quite sure how much preload to put onto the bearings, so I made a series of shims. Now these shims go into the hole, okay, and they have the effect of moving the preload collar or preload washer out and compressing it more. So I've done a bit of trial and error and came up with these. So it's about 3 mil, give or take, of shims. Now, even the shims, the engineering that goes into the shims, you might think, well, I'll just make it the same size as that. Well, if you did make it the same size as that, as in the interior diameter, you won't be able to get them out. So the interior diameter is slightly smaller. So if I load this up, okay, so that's gone in. And if I look from the other side, hopefully you can just about see a lip in the end. And that's so you can poke it out in case you need to, because one thing that happens is the spring will lose its tension over time, or compressive force over time, so you have to allow for that. So periodically with a Campag crankset, you'll either have to change the wave washer or re-shim it. I haven't pushed that in properly. There we go. Okay, so that is seated all the way round. I'm going to pull this off and then pop that in and just give you a steady spin test to show you it going round. So let's pull that off. That is the non-drive side. So these are the 6mm bearings, so it's designed for 6mm. You could, just by shaving a millimetre off, make it work with just standard 605s. I do not expect the spin test to be very good because, as I mentioned previously, the seals on the outside are seriously draggy. So pop that in there, and then we just push that to make sure we are on the spring. Now you're seeing probably the culmination of about 5 or 6 hours of genuine fucking around to get this to work. It's not simple by any means. Okay, then pop that through like that. Make sure it's indexed correctly. So that means the hearth teeth are in the right position. And we should be able to just lock this up. So as I mentioned previously, this is not going to spin well because of the seals. Yeah, you can see the drag instantly. But it's smooth. And it has just the right amount of preload. So that's okay. So now we can put this into the bike. Right, so first thing is we're going to put some grease on the inside of here. Check for any burrs. And then we need to put the bottom bracket through. So we've got that piece and that piece. Okay, right. So I've just got this going. It's a bit misaligned, but that will correct itself shortly. Okay, so we need to now undo this. So I've just reset the press to give the final squeeze. So the lock ring's going in. Like that. And we are all done. Just clean the excess grease off before we do the final assembly Now on this bottom bracket, well, this crankset, the bearings are a loose fit into the balls, so we'll just add a bit of grease into there. I know it probably looks a bit weird that I've just taken all the other grease off, but it's round the outside, so just add a little bit. Okay, then we need to get the crank set. So this is the non-drive side crank arm with its cult bearing already installed, and this is the wave washer. There's already 3mm of spacer in there, preload spacer, so we pop that on. Just make sure that the spring is engaged, and then we can put the other side on. Not quite right. But the index, there we go. The index is right now, correct. You can do the crank bolt up. Oh no, I've got it right. Try again. I think we're one tooth out. Okay, it looks to be right this time. So that is home. I'm not quite sure what the torque setting is supposed to be for that, but to be honest, it doesn't matter for this test. So I can peel this sticker back down and then give it a twirl. So obviously there's a lot of drag in there from those seals, but that does go around. So that is a Campag BB65 bottom bracket. So there we go. Now, some fuckstain on the Tor forum, I think his name was Heinrich, and he likes Kölsch and he lives in Dusseldorf, said this was going to come out. Not sure why he thought it was going to come out. Probably because he's more intelligent than I am, but it won't come out. So that is a Campag BB65. You know, you've got a shot from both sides there on a look frame. The fucking around this preload system, Jesus Christ, what a fucker. Yeah, so that's where we are. So that brings us to the end of this video. I really hope you enjoyed it. If you did, remember to whack the like button and leave your comments below. I do try, well, I'd read them all, but I do try and respond to a lot of them, but it's just, you know, if I could respond to them all, I would. I haven't got the time. I mean, on a you know, final thoughts, this look frame, the 695, is really the gold standard in terms of bottom bracket design, and this is well made, this frame. There's no two ways about it. This one and the one I had before and a few others, they've all been well made. The Campag Crankset, it's well engineered, but there's some serious, I don't know, fuckwittery around some of the engineering things, like you know, using non-standard bearings, then using very low friction ceramic bearings, and then whacking on the most frictiony seal that you can get. It just sort of defies a bit of logic. And then also the business about using the crank bolts. One's left-handed on one particular group set, and it's right-handed on all the others. So I don't know. Anyway, that is the end of this video. I really hope you enjoyed it. Until next time, thank you very much.